This video is on capacitive reactance. It's part 3 of a series. This video deals with adding capacitive reactances in series and parallel. So initially we were learning about capacitors when they're in series, and when you add these in series, well, you use this formula right here, the reciprocal formula. But when capacitors are in parallel, we just add them regularly like this. So the question is, how do we add them when they are in series and parallel? So let's get right to it. So first let's deal with series. So here we have two capacitors in series, and we have the reactance that's known for both of them. So the way you actually add these, when they're in series, it's quite nice because they react just like resistors. So that's how you add them. So the total reactance for this circuit would be the reactance of 1 plus the reactance of 2. And then you just plug in the values. So you would say 10 for the first one plus 23 ohms for the second. So the total reactance of this circuit in series is just going to be equal to 33 ohms. And that's the nice thing about the reactances, is because since they're ohms, they just act like resistors and you add them just the same way. So when we get to parallel, it's going to work the same way as resistors in parallel. So here we have C1 and C2, and so we're going to figure out what the reactances is for this circuit. So the reactance would be 1 over the total reactance is equal to 1 over the reactance of 1 plus 1 over the reactance of 2. Now, since they work just like resistors, you could also use this formula to solve for them. Since there's two of them in parallel, you could say the total reactance of these capacitors in parallel is x1, or the reactance of 1, plus the reactance of 2. Oops, I'm sorry, it's not plus, it's multiplied by. Oops. So it's the reactance of 1 multiplied by the reactance of 2, divided by the reactance of 1 plus the reactance of 2. So now let's work these out real quick. So we have 1 over the total reactance is equal to 1 over 2 plus 1 over 4. Let's give a little more space. So now 1 over the total reactance is equal to, now we want to find the common denominator here, so we could add these together. So we're going to get 2 over 4 plus 1 over 4, which is going to be equal to 3 over 4. Now, here, we want to flip these, and the reason you want to flip these is because you have the ohms down here in the denominator, and you don't want it in the denominator. You want it in the numerator. So you're going to flip these. So you're going to get the total reactance is equal to 4/3 of an ohm, or 4/3 ohm. And you do that because now the ohms are on top and not in the denominator. So now let's see if our other formula still holds up. So using this formula, we're going to say the total reactance is equal to 2 multiplied by 4 over 2 plus 4. So total reactance is going to be equal to 8 over 6. And if we reduce that down, we're going to get the total reactance is equal to 4/3 ohms. So that's how you solve for that one. So yeah, reactances can be pretty nice because they act just like resistors when you're dealing with series or parallel. So yeah, I hope this video made sense. I hope you enjoyed it, and I hope it helped you out. So good luck in your classes.